Hi, my name is Vadim and I'm happy to present our paper on few-shot adaptation of GANs. This work is done in collaboration between Bosch Center for Artificial Intelligence and the University of Bonn. Our work is concerned with training generative adversarial networks with limited data. Imagine that you have a very small dataset of rare images, such as this collection of 10 Van Gogh paintings. It is well known that training GAN models from scratch on such small datasets does not lead to good results. For this reason, the community attempted to avoid training from scratch in such extreme scenarios. Instead, it became common to employ GANs that were pre-trained on much larger datasets, such as Elsan churches is in this example. Such pre-trained models achieve good synthesis quality and are typically easily available online. As was shown in prior work, when using such model as a source for fine-tuning, it becomes possible to avoid instabilities, mode collapse, and transfer the diversity of the source domain to the few-shot target domain. In effect, the quality of the target GAN model improves. However, as demonstrated in our experiments, this approach works well only when the source and target domains have similar structure, for example, having the same shapes of objects, such as churches and Van Gogh houses. In contrast, when the two domains are not similar, the performance significantly degrades. This brings the following issue. If the target few-shot dataset belongs to a rare domain, as in this example with shells on black background, it has no compatible pre-training datasets. In this case, fine-tuning a GAN from a distant source domain leads to poor performance, for example, failing to adapt shapes of objects. To extend the applicability of few-shot GAN adaptation, in this work we aim to address this limitation and study the following question. How to achieve good performance by adapting a pre-trained GAN from a dissimilar domain? Our method has two GAN models, a source model which is kept frozen and a target model which is fine-tuned using limited data. Our idea is based on the following two observations. Firstly, when trained on sufficiently large data, the source generator produces smooth latent space interpolations with realistic image transitions. Secondly, these image transitions have remarkably general nature. We hypothesize these two properties can be transferred to the target generator and assist image generation even in distant domains, without compromising the shape of objects. For example, as shown in the image, we can regularize the generator in a way that latent directions causing the translation or zooming of the churches cause similar effect on shells. We implement such smoothness similarity regularization based on the Jacobian matrices of both generators. Next, we revisit the adversarial loss of the discriminator. Typically, a discriminator is structured like a classification network, taking an input image and producing a single score about the image realism. In case of very limited data, this solution is prone to instabilities due to easy memorization. An alternative solution is patch count discriminator, computing the loss at an early intermediate discriminators layer. While this solution helps to overcome memorization, it still fails to adapt shapes of objects to a new domain. Our idea is to provide the discriminator with the flexibility to compute the adversarial loss at all layers simultaneously. With this solution, the discriminator can automatically discover what part of network is more relevant for a given dataset and consequently stabilize the adaptation of object's shape to new distant domains. Overall, our model is trained with two losses, the adversarial discriminator loss and the smoothness similarity regularization. Here is a visual comparison of our approach to prior methods, shown for a 10-shot adaptation from Elsan Church to shells. We note that in such a challenging case, prior methods suffer either from training instabilities, mode collapse, or inability to adapt the shapes of objects. In contrast, our method achieves good image quality, generates objects combining features of multiple target images, and meaningfully transfers the geometric diversity from the source dataset. More visual results are shown in our paper. We compare our method quantitatively on different source-target dataset pairs. Our method outperforms prior works in image quality and diversity in the challenging case when source and target domains are dissimilar. In case of more similar datasets, our method performs on par with prior work. In summary, our contributions are: we propose a new evaluation protocol for few-shot GAN adaptation between dissimilar domains. We introduce a new smoothness similarity regularization and a new scheme to compute the discriminator loss. Our approach for the first time enables successful few-shot GAN adaptation from a distant image domain. Thank you for your attention. For more details, please see our paper.